Hey guys, hope everybody's doing well. Hope you all got to see some good talks today so far, and hopefully you'll enjoy this one as well. Just a quick show of hands, was anybody here at the Security Engine conference yesterday? Okay. Fair warning, this talk will be fairly similar, in fact very similar to the talk that I gave yesterday. So just trying to give you a heads up there. Just in case there might be another talk that you're interested in as well. But without further ado, I'll go ahead and begin. So again, my name is Wes Lambert. I'm a husband and father of 4, also known as the co-manager of household operations, right? So I love cheap coffee, yes, cheap coffee, Indian food, and I also love free and open source software. Yes, thank you. Yes, especially open source security software, right? Like, you look back maybe 5 years ago versus now, and we've really come a long way with being able to share the tools that we have or that private industry has had with the community, and I think that's pretty awesome. And that's what I'm going to be talking to you about today. So, quick show of hands, who's used Security Onion before? Okay, awesome. Awesome, because this talk will assume that you have a fair knowledge of Security Onion or have used it before, but I'll still go through some of those data types that we provide and how it can be a benefit to you regardless. So just before I get into that, yes, I am the senior engineer at Security Onion Solutions, or a senior engineer. We have several now. The company's been growing at a pretty good pace recently here, and I'm pretty excited to see where it goes. And just real quick, so what Security Onion Solutions is, of course, the platform is completely free and open source. We just provide training and support for the platform. All right, so again, an introduction. We've really come away from that black box approach of just trying to prevent everything from getting into our network, right? We really have to step away from this approach and take a step back and look at really, why or how these people are getting into our environment. And we have to have ways to detect that. So we know, or we should know, that bad guys will get in at some point regardless, and we need to find a way we need to have a way to find them. So again, we need to substitute detection for prevention. We need to find a way to retrieve that data that we're recording about our network. We need to make sure it's easily digestible. We need a way to correlate it with other sources, other data. We need context. We need to build upon network security monitoring principles and implement enterprise security monitoring so we can bring in all of that host telemetry and all that other good data that can provide that good context around the events occurring in our network. So some of the data that Security Onion itself provides is going to be of the above. So we have alert data, things like IDS alerts from Snort or Suricata. We have session data from Bro, transaction data from Bro, stuff like HTTP or DNS traffic. We have full content data, stuff like PCAP from NetSniff and G. We have host data that we can bring in from Wazoo agents or beats. So that's going to be Elastic's mechanism for bringing in those host logs like WinLogBeat or FileBeat or something of that nature. We also have things like sysmon and auto runs that we can collect via stuff like WinLogBeat or FileBeat. Stuff like that. We have alerting, so we can alert on this data that we collect, right? And also the data enrichment and visualization that we provide is going to be by leveraging the Elastic Stack. So Elasticsearch, Logstash, and Kibana, of course. I'm sure many of you have heard of it. Who has not heard of it? Okay. All right, so continuing, we want all of that data, and we need all that data, but we do not want this data. Right? Well, I don't know, maybe for like AI or some kind of cool machine learning type stuff. I don't know. We'll see. Keep that in mind. All right, but again, that alert data is going to be like that Snort or Suricata alert, something that you might view in Squeal or Squirt like this. That session data, looking through Kibana, you can see that Bro data that's going to be similar to NetFlow. Think about that con log, right? It can identify a certain service type, but it's not going to give you many more details beyond that NetFlow type data. Did I go back? I went back. So that transaction data, that we talked about, again, is going to be like HTTP traffic, DNS, DHCP, giving you more details about the actual transactions that are occurring. Extracted content, so things extracted out of the network streams, like EXEs, extracted from Bro's file extraction framework. We can do things like this, to, like send them to a sandbox. We can use something like file scanning framework or Strelka, which I'll talk about in a little bit. And of course, that full content data, that PCAP that I was referring to, that whole transcript or that conversation that we're recording off the wire. And of course, that host data, so Wazoo agents, WinLogBeat, OS query, Sysmon, all sorts or sources that we can bring in and enrich our current data and provide more context. And again, the alerting that I mentioned. So this alerting is going to encompass things like destinations from ElastAlert. So what ElastAlert will do is run in a Docker container, and then it's going to query Elasticsearch for any conditions that you specify. This would be similar to if you query Elasticsearch or Kibana. So you can see this type of query here that we have on the screen, event type snort. So any events of type snort will trigger on that. And right now that alert type in the description is just debug, so it's just going to output it to a debug log. But there are several destinations like email, Slack, Jira, and lots of other good stuff. So we're not done yet, though. We need more, right? We need more detection mechanisms. We need more context again, more response mechanisms, and of course, more cookies, right? Everybody loves cookies, so we need more of all this stuff. So one way to get more is to implement something like Sigma, right? So has anybody here implemented or heard of at least Sigma rules? Okay. So to the uninitiated, Sigma rules are going to be really a generic format for rules for something like a SIM or an IDS or something that behaves in that manner. They're going to be in YAML, written in YAML, a very well-defined syntax. And it's going to be vendor agnostic and allow you to easily share these detections, right? And the great thing about Sigma is that, again, you have this syntax right here. So it's pretty convenient and familiar for many folks who work in InfoSec. There's a lot of tools that rely on YAML config files or in other institutions. So you can see that example there. And the great thing about Sigma in particular is the guys that maintain the repo, Florian Roth and Thomas Patsky, also have the Sigma converter, right? So we can take the Sigma converter and we can convert these standard Sigma rules. They have a ton of example rules in their repo. And we can take these and use these with something like ElastAlert. So we run this command like so, as described up here, the sigmac-t ElastAlert and so on. And then we can generate ElastAlert rules from these standard Sigma rules. And we can also apply automated processes to this. For example, Josh at Security Ending Conference talked about his playbook initiative where he's taking these Sigma rules and you just paste it in and then we're converting them to ElastAlert rules, right? And then they're placed in the ElastAlert rule directory and you don't have to touch it. You don't know you don't have to know how to write an ElastAlert rule. You don't have to mess with the Sigma stuff. You just paste it in and go. So a tool like Sigmac is very convenient in that manner. So another tool we're going to talk about is MISP. Anybody messed with MISP or heard of MISP at all? Okay, cool. So MISP is another open source tool. It's a platform for sharing threat intel. It provides the ability, of course, to correlate with from different IOCs and entities and things of that nature. And it has a really rich API to be able to pull in this data and use it in other applications. So one of the concepts or constructs of MISP is the concept of an event. So within an event, you might have various information, such as attributes that reference the events, or it might have maybe IOCs that you've extracted that are relative to the event, and you paste it in there with it, a threat level, an analysis level, and various other details to give you more context around what's going on with that event. And so the thing with MISP is that you can share these different events and attributes among organizations and among communities and different MISP instances. So essentially anyone with a MISP instance you can share with each other, And then from there, you can go on and do as you wish with these IOCs. Now, keeping in mind, of course, all IOCs are not going to be high fidelity, so you definitely want to vet your sources and make sure you do your homework when using some of these. Again, I spoke about attributes. So an event can contain several, if not many, attributes. These types are going to include stuff like source and destination IPs, registry keys, file names, hashes, things of that nature. And like I said, you can add as many of these to an event as you want. You can tag these attributes with certain tags, like if it's relevant to C2, or maybe the Fallout exploit kit, or whatever you would like to do, cybercrime, any type of fraud, however you would like to do that. Another thing is the concept of feeds. So these events are typically generated. You can have them auto-published or not published at all through these feeds. And these feeds, Mist comes with a default set of feeds and different feeds available. But I would definitely caution you to not select all and import these feeds because you would have a lot of work on your hands. No, but let me log back in here and I'll give you a look real quick. All right, so let's go to All right, so this right here, this is going to be an example of some of these feeds that you can pull in. As you can see, you see some of the Zeus stuff up here, emerging threats block rules, and these enabled and caching enabled flags. So I've got one enabled here, a malware domain list that maybe I'm using to generate some rules or some other IOC data. But you can mix and match different ones. But again, I urge you not to select them all. And these are really just examples that you can pull in unless you're using some of your own feeds or custom mechanisms to bring IOCs into the platform. Let me go back to here. All right. So another thing with these feeds is that these attributes can be used in IDS signatures. So if you're a security onion user, you may be familiar with the Bro Intel framework and the fact that you can use local rules to implement your own rules with Snort or Suricata. Right? So these feeds can be exported and used in these signatures. So right here we have an example of the export types that you have, right? So we see Bro, Snort, Suricata, we see JSON. If you have some other system that you want to pull this into, we have all this stuff available at our fingertips. And again, I mentioned that API makes it very simple. So the API, they do offer, the folks that work on MISP do offer a Python client known as PyMisp. I believe the updated version may be expanded PyMisp. But what this does, it allows you for the ability to conduct automation, right? The things that I mentioned, the NIDS export for Snort, or Suricata, or Bro. You also have Elasticsearch Enrichment opportunities, which I'll talk about in just a second. You can add sightings for a particular IOC. You can manage users and do all sorts of other cool things. So this Elasticsearch Enrichment that I mentioned, this is one way to take these IOCs and then enrich your existing security onion data with this data, right? So you can take in these IOCs, and then in the pipeline, you can enrich your Bro events or other events to see if you get any particular hits. And then you can refer back to these hits in MISP to get a little more context on that particular event or gain additional insight into other attributes that may be present. So what I've done here in this example, it's basically a Dockerized method to do this. There's a guy who did this on Twitter a little while back. His Twitter handle is DCSecurityDK. But the concept is pretty much the same. Some of the configuration is similar, but I've just Dockerized it and made it a little bit easier to run. So essentially what happens is that we query MISP, right, using this Docker container, and then these values get populated into an in-memory Memcache database, and then Logstash pulls that database and then inserts that enrichment into the event, and then, of course, indexes, pushes to Elasticsearch, and Elasticsearch indexes that data, then we can see all that goodness in Kibana, right? So an example of that, real quick, we can see. So let's go back to my event that I have over here. Onions are us. Da-da-da-da-da. Let's do this. All right. Oh, let me go back home. Okay. Cool. Okay. Yeah, let's do this. I want to go here. What am I doing? Why is it not? Attributes. Okay. Sorry. Squirrel brain for a second. Anyway, we see these different values here. We'll see some different values, such as these SHA-256 hashes and the domain down here, online dating for live.info, right? And then we see some tags associated with these. Oh, whoops. Sorry about that. Thought it was going to be duplicated. Why is it not? What the heck? Well, you need to refresh the, oh, it's still on the, it's weird. Let's kill the slideshow. What the heck, man? Yeah, can you try refreshing maybe? See, it's still on the, I'm not even in the slideshow though. All right, let's do this. Cross your fingers. Yeah. Wow, wigging out. It's wigging out. All right. Yeah, it's thinking really hard. I got all these VMs running. It's killing the box. There we go. I think we're back to basics, right? All right. Cool. All right, we're back in business. All right, now what I was talking about. Sorry about that intermission. All right, so these SHA-256 hashes over here. Yeah, okay, so you can see them up here. And then this domain, online dating for live.info. We have those in the MISP events. All right, and then we're using that Docker container. Using that Docker container, right, to pull in all that stuff. So just do docker ps MISP. All right, we see it running right there. All right, and let me just do a history. grep 4. All right, 7. All right, and then what I'm doing right here, I'm just looking at trying to show you guys, looking at that Memcache database. You can see all these entries on here, this Hive domain right here, which I'll talk about in just a second. And we also see a domain, online dating for live.info, and those SHA-256 hashes right there. All right, so that logstash pipeline config that I have in Etsy, logstash custom, it's going to cat 8300. This is a logstash config, and just to give you an idea, I'm basically looking at these fields, and if they exist, I'm just going to make a lookout to memcached, and then I'm going to look for that prefix, right, like hash MD5 or MD5 or domain. I'm going to get that, and I'm going to pop that into a field called MISP match. Right, so let's look in Kibana here. All right, see if we get any hits. Why are you stuck? Okay, there we go. All right, so we get a couple hits, right? How about this? Okay, we get this MISP match, and it's tagged with Fallout. Seem to remember seeing that tag over here, right? So you can tag these with, of course, more descriptive type things. If they're default tags that you have in your organization, you can, of course, use those. And you can, of course, do a number of things. This is just really intended to give you an example of what's possible. You can go from here and do crazy things, right? So I see that it's tagged. I see that, of course, I got this match from MISP, and then I can go check it out real quick. And why is it not? For some reason, I don't know. Well, my search is not working right now, but that's the main idea is that you can pull in this data and enrich your existing Elasticsearch data with it, right? And then so we've taken that IOC, we've ingested it into our detection pipeline, and now we're enriching our data with that. So another thing is the NIDS rules and the bro intel, right? So we can take these, we can pull these down via the MISP API, and then we can implement those into our detection pipeline as those snort or suricata rules or that bro intel framework. And we've got kind of the workflow here, of course. We have a bash script that we can run, right? We can query for NIDS rules via the MISP API. We can push those out. We can pull them in. And then once we pull them in, we get things like this. All right, so I'm going to show you in just a second what it actually generated, but you can see in Kibana we have NIDS alerts, so things from snort or suricata from those MISP IOCs, right? It's tagged MISP E1 fallout, outgoing HTTP domain, online dating for live.info, exactly what we had in MISP, right? So you can see how we can leverage this threat intel to augment our pipeline. So just to give you an idea real quick what that actually looks like, on disk, all right, and it's a little hard to read, I'm sure, but you can see here the snort rule that was generated and populated into the downloaded.rules as a result of rule update running and pulling in those custom MISP rules. But it can be very powerful, again, in pulling that stuff in and augmenting that current pipeline, like I said. And again, so these things that I'm presenting, of course, aren't meant to be, just things, go take and run in production or whatever. But just to give you an idea of maybe some POCs or things that you can take and run with. And now some of this code I've documented on some of these slides. Will be in their separate Git repos, so you can go pull that down and mess with it if you want. Tell me how bad it is. Tell me how good it is. Make it better. So just let me know. So another tool that we're going to talk about is the Hive. Anybody here familiar with the Hive? Awesome, awesome. Okay, so the Hive is an open source security incident response platform. It's super awesome. We're actually going to be integrating this natively in our Hybrid Hunter security and in Hybrid Hunter release that we're currently in the works with. But it's used for tracking those incidents, right? Like as a team. So going in and maybe you get this alert and you need to go investigate something and you need to attach observables and you need to have tasks associated with it. It's very good for that, and I'm going to talk about that in just a minute. It integrates well with MISP. They do a lot of work together to integrate and benefit each other, and again, gather more context around events using each other's tools. It has a very feature-rich API as well. So a core concept within the Hive, of course, is going to be cases. Typically with an investigation, you might have a case that you're working, right? So it's going to be populated with different observables and different information based on whatever you're doing, right? Like maybe a threat level, tags, or things like that. Another feature that's pretty useful within the Hive is the ability to apply case templates. Right, so what a case template is, it's going to be a template that you can apply to an alert when it's imported as a case. So typically with a Hive, you'll receive an alert, and you'll review that alert. And from there, you can decide if you want to ignore it or mark it as read, or you can import that into a case. And a case template allows you to define repeatable functions, right, that maybe an entry-level analyst might perform, or even stuff that, if you have a lot of stuff that you do regularly that you don't want to keep reminding yourself to do, or maybe you're not sure of and you don't have to keep looking back, just put it as a task in a case template, and then it'll be generated in the case every time you go to perform an investigation that's based on particular attributes. For example, if you have an alert that contains the word Trojan in it, or ransomware in it, you can have a case template based on that, right? So you can basically have it import those tasks based on whatever you're looking for, or whatever you're looking at. Again, those alerts that can be generated from a noteworthy event from an external source. And it'll offer maybe a snippet of what may be going on, of course, but you're going to have to do more investigation to get more context. It can be merged into a case if further investigation is needed, as I mentioned just a second ago, or it can just be discarded. again, those observables that I mentioned, they can be IP addresses, domains, hashes, actual files, things of that nature, or something else, altogether. You can define your own observable types for your organization, and you can go from there. Another function or feature that ships with the Hive, or at least is native to the Hive's core framework, is going to be Cortex. So Cortex has these things called analyzers. So they're going to take the data in the cases, right? And you can run these analyzers against them, and then you can get more context around them, right? So you can get more data about them, or at least some kind of reputation, or help you make some determination on these. Some of these default analyzers include Cuckoo Sandbox, so you could send a file to the sandbox automatically, right? Gray Noise, you could look up the reputation of the IPs, right? MISP, I mentioned that before, and many, many more. Again, the Hive offers a feature-rich API. You can use the Hive-RPI Python client, and you can create a case from that. You can attach observables, right? You can attach a task to a case with the API, and you can also raise an alert, which can be pretty useful from external entities. And right here, I've got an example, basically where I've run a flow, Google Gur, and then I've attached the resultant zip file using the same Python script to the Hive, right? So these are just examples of how you can automate processes and add that context into the event, and go from there and hit the ground running when you see that alert. Now, another way that we can alert to the Hive using that API is going to be ElastAlert. So we have this in our documentation down here at this link, but you can create an ElastAlert rule to use the Hive alerter, right? So what this one does right here will match for any alerts. Right here, it actually doesn't show that. Yeah, it does at the top. Okay. Event type snort. So we're going to alert on any IDS events, right? Any NIDS events. And then we're going to push those to the Hive, and we're going to attach the source IP and the destination IP. So it's pretty cool to be able to do that. But you do want to be careful with the types of events and the volume of events that you're pushing, of course. There are different options in the ElastAlert rules themselves to help you limit that. And there are also different filtering techniques you can use with that query or the search terms there. Now, that's all fine and dandy, but what if we want a little bit more, and if we want to, maybe we want to push it from something like Kibana, or from a web interface, and perform a little more automation in that manner. So we can certainly do that with the Hive and with some other endpoints. So another thing that we can use is something called Octopus. And kind of silly name, but it's like an octopus for the sock, okay? So what we think of here is reaching out to different endpoints and performing different actions based on whatever you're trying to do or whatever you're looking for, right? So we have some endpoints here in Octopus, again, that Flask API. We have some different endpoints for the Hive, MISP, RTIR, FIR, Gur, planned for Velociraptor. You can do it natively with Slack and also with Strelka. And again, this is something that it's kind of at least with the current security engine is more of a POC, but will be something that's natively integrated in this next Hybrid Hunter release that I'm mentioning. Again, the date on that is not necessarily confirmed, but just keep an eye out for blog posts and other info on that. But you will be able to use Octopus, or at least mess with it, in the Alpha Hybrid Hunter release, Alpha 2 we just released yesterday, so you can check that out. And also from my GitHub repo, you can add it to an existing deployment. So some things that you can do with Octopus. All right, say I've got an event here, right? Let me go to a different event, actually. All right, let's do this one. So, all right, I got this event, right? A network Trojan was detected. So kind of the methodology here is that, you've got events that you want to automatically alert on, right? Maybe high fidelity alerts. Maybe you do that with Elastalert and send it to the Hive or somewhere else or to MISP. But maybe other ones that you're not sure about or you come across when you're hunting, right, in Kibana. You're aggregating data, you're looking at stuff, and then you see something that looks unusual. Maybe you want to push that to somewhere for further investigation. So we can do that by simply clicking this link here, send to Hive. It's going to take this NIDS alert, and albeit this is done a little bit better in Hybrid Hunter, it's formatted a little bit better. But what we can do here, we can see that, all right, 1445, ET Trojan, Vidar, Stealer, client data upload. We see that here. We can preview it. We've got a description of that alert there. We've got some observables, a source IP and a destination IP there, right? And these are going to be agnostic, source and destination agnostic, because when you're searching through these, you want to see the matches, right, unless you're doing your own filtering. And then we've also got the sensor here and the interface name it came from. And so, if we had case templates applied, we can import this into a particular, Trojan or infection template or something like that, right? So there's lots of stuff you can do there with regard to the Hive. You could go further and add additional Cortex analyzers to enrich that data. But, at least part of the data, taking the data, copying, pasting, going and creating an event, doing all this other stuff, you can ignore that. Yeah, nothing to see here. Yeah, that's actually not an artifact of the Hive. That's more of the way I have it set up right here. But yeah, I mean, it's more about expediting that process and getting more of that context more quickly. And we can do the same thing with MISP, right? We have an endpoint for MISP. Let's see if we can send it to MISP. All right, so there it is. We just sent it to MISP. We can list any attributes. Well, oh wait, that's not the event attributes. Sorry. Scroll over here. I know why I wasn't able to see it earlier. All right, yeah, so we can see this event here, and of course it's going to have that alert populated into the info data, and you can go from there adding additional attributes, or you can populate those through Octopus, right, with a little additional effort. So that's pretty cool. This is just some examples, right, of how you can use Octopus or that Flask API to go ahead and try to automate some of that when you're doing hunting or other types of activity. Yep.
Question, so when you begin to triage an alert for something like Hive, are you doing any type of document update in the bond that other analysts would notice that alert to be triaged?
No, I have considered something like that, honestly. So using the update API to update a field or add an additional field, right, like you're saying, an acknowledge field. So that's something definitely that I've considered and may pursue, but that's a really good question. Yeah, we actually considered using that, actually performing an update and using it kind of like a queue, but it just, I don't know, there wasn't enough stuff there, I think, to really orchestrate that really well, and in a large fashion. When I don't know, you get what I'm saying? You're allowed, yeah, you know who you are. Yeah. Yeah, I'd love to talk about that more, though. Let me get you from current slide. All right. So another great open source tool, Velociraptor. Has anybody heard of Velociraptor? Okay, anybody heard of GUR? Google GUR? Okay, so Velociraptor, Michael Cohen actually used to develop, help develop Google GUR. He used to work at Google. Now he's at Velocidex. Right, so Velociraptor is kind of a fork of GUR, or really a rebuild based on a lot of the principles, maybe. GUR is really rigid in nature, and Mike's vision here, I think, was to kind of take away some of that complexity and rigidity and allow people, like incident responders, to really use the tool to what they want for what they want to look for, and not use what's provided what you have to use. So they make it very easy to integrate with and to customize. So again, the focus there is simplifying architecture and improving performance. Performance is pretty good compared to GUR, I have to say, not to bash GUR. By default, it performs no analysis itself. The data collection is really that primary use case. And it's got its own syntax, similar to SQL, called VQL or VQL. That's, of course, there's a little bit of a learning curve there, but once you get familiar with that, it can be very powerful. Sorry, get some water. Second, please. So, ways in which you can deploy Velociraptor. There are a few different ways. A standalone deployment, of course. You can install it on a box. I've got it on a demo box right here. Just standing it up. It's a Go executable, right? So I just execute that Go binary, and go from there. And you can deploy it in the cloud. You can have agents deployed on machines and reach up there and have your master server or your Velociraptor server in the cloud, which can be pretty convenient if you're going on things like client engagements, right? And going in and connecting up stuff, or you have distributed stuff, all over the place. And you can interactively triage. You can take it, go run it on a host, collect the artifacts, and then go analyze those artifacts. So it's pretty flexible in how it can operate. So that VQL I mentioned really is that framework for creating these highly customized artifacts that you can collect, right? And you can pretty much create your own artifacts to look for pretty much anything you want. And some of these artifacts, they're going to be different types, like client artifacts, right? So client artifacts are going to run directly on the host. Things like process creation are going to be monitored, network events. And then, you can perform post-processing on those later using these server artifacts. So you can look at all these different things, right? And then filter out certain things, and then find what you want to look for, and then either alert on that or do further post-processing on those artifacts. And other things you can do. And actually, this is not released yet in an official release, but you can use stuff like Elastic Flows uploads. So you can stream this directly to Elastic. I believe they use the Go Elasticsearch plugin there to do that. But again, this was just committed a few days ago, so it's not in an official release, but should be very soon. So given that, we can stream client artifacts and these server artifacts straight to security and running the Elastic Stack, right? So it's pretty neat to be able to take that data and then easily aggregate on it and review that information and tie it in with all these other data sources that we have, again, providing even more context around events occurring in our network. To give you an example of that, and real quick, just to show you Velociraptor. So I've got it running here, the server. It's fairly simple interface, kind of no frills kind of thing. Let me see if I can go back home here. All right, so this is just the, the interface here. Just the server status here is what you've got up front. And you got some other things here, like the hunt manager. You can view different artifacts that you want to create or edit. So if I look here, I've got one right here, a custom Elastic Flow upload. And you can see some of that vQool there. But I'm basically specifying to send this off to Elasticsearch here after I post-process these client flows. Let me go down to, where is it? Okay, the host here. So I've also got a host here. It's a Vagrant box, Vagrant 2016. And you can see all the data that was collected on this host, all these flows that were run on here. You can see the different results here. Right? And just to give an example of some of these, so you see these registry mount points, you see network listening ports. So this attack stuff is based on the MITRE ATT&CK framework, and so I think they were generated from the OS query packs. But you see other stuff like prefetch, evidence of execution. I mean, there's just tons of stuff on here, so if I search Windows, and it gives you an example of each of these. So you see the applications, Chrome, Chocolatey, Office macros, all this good stuff, right? Volume shadow copies, right? VSS. You got Kerberoasting you can detect, right? You got forensics file name. You can search for files, right? You can do a forensics timeline, CAPE targets. So if you're running CAPE and you got CAPE targets that you want to collect, you can do that. All right, this NTFS I30 can check for deleted files, right? So right here you can carve the I30 index for a directory, right? The stream. Let's see, what else? Where is it? Where is it? And there's also, so stuff like, ooh. Yeah, so you can also use Yara, right, to scan process memory, and then you can stream those results back to Elastic. It's pretty powerful whenever you consider, the ability to perform this remote forensics. You can do this across a whole fleet of hosts, right? You can schedule hunts across all your hosts and look for different files or different artifacts like this, and then have them streamed back to Elastic. And to give an example of how you can visualize that, I've got a dashboard here. Where it's sending it straight to Elastic. Let me do this. So I've actually got 2 hosts that reported, but you can see all this different data, right? You can see my artifact count here. You can see the different artifact types, system services, the network stuff, attack stuff. You got the different host names here, different sources for where these artifacts came from, right? Different names of processes and artifacts and file names. Just tons of stuff to pour through. I'm not going to go over right here. But you can see how far you can take this when you're doing your investigations and then stream the results right back in, then have it for review for later or for now, right? So then real quick, I just wanted to show you, let's see, I guess one last thing. I've got about, let's see, it's probably like 7 minutes here. Strelka. So one last tool I'm going to discuss is an open source file scanning framework. Not file scanning framework, or file analysis framework and file scanning system, sorry. It's written in Go and Python 3.6 with gRPC, and it's awesome for using to take those extracted files that Bro produces from your network sensors and then send those off for further analysis, right? So a few use cases here really going to be things like extracting nested files from other files, right? So identifying malicious scripts in files. Looking at import functions for Mac O, MZ files, and even Linux ELF stuff, right? And you can even, from Strelka itself, you can send that stuff to Cuckoo or MMBox to get reputational information or things of that nature. Scan results are going to be native JSON. You can specify a snake or camel case. It's got built-in log management and compression. Certain features, some of the things, examples of things that it'll provide other than, the tons of other useful data, things like entropy scores, right? So you can check for compression or encryption, potentially identify ransomware. Check imp hashes, right? And those import functions I referred to are going to be super useful to be able to look at, especially, looking at those import hashes and other things. Other different hashes, tons of hashing that goes along in there, like SSDeep. What else is there? Of course, the imp hash, SHA-256, SHA-1, etc. And then we can also take, this extracted file name. We can tie this in Kibana. Then we can pivot over from the Bro or to the extracted Bro file, and vice versa. So, how it all integrates really, again, we can bring all this data back into Elasticsearch and look at it in Kibana and get, again, more context, right? So say I have a Bro, I have this extracted file that I want more information on. And this is, again, is going to be helped by Octopus to help automate some of this, but there we go. All right, so what I'm looking for here is just a Bro files entry that has an extracted file. So it's going to be residing on that network sensor where it extracted it from the network stream. Oh, goodness, I am the worst. For some reason, it keeps getting stuck whenever yeah, that good? Better? Yeah, okay. Yeah, for some reason it keeps, I don't know. I'm the worst. All right. So, yeah, I'm looking for any entry related to the file that was extracted. I want to get more information about that file, right? So I can click here, scan with Strelka. All right, what I'm going to get a screen saying that this file has been processed, and if I want to search for it, I can go do that. So it's going to take just a minute. I do have a cron job running that's actually looking for any jobs that want to be executed, and then it's going to go take that, and it's going to go copy it over to a directory where I have Strelka monitoring. So this is useful if you don't want to run Strelka on all of your extracted files and have to have all of that log data or all of that performance hit, then you can do it on demand like this, and it's very useful in that manner. So then if I go back, and search, I'm just going to do the last 15 minutes. I don't get anything just yet. I should in just a minute, though. We'll give it a second. But what we'll see is that it will, it'll populate that and perform that on-demand scan. And it's very helpful, again, for conserving resources, disk space, and all that kind of stuff. So here it is. All right, so we actually got 9 hits. That's because this particular executable has, is comprised of these 9 different sections, right? So there are different scan results for each of these that we can go through. We've got just a minute here. I'll try to show you right here. All right, so we can see the different scanners that it's using. The file scanner right here, we get some different file information. The scan PE section, you can see right here. The file source, we get hash information. And if we scroll down to this one down here, I believe it's this one, we get all sorts of goodness that can later, honestly be parsed into their own fields. But all this stuff from stuff like exif tool, right? So you might run exif tool manually on files. This does all this for you, right? So we see these different keys like source file, exif tool version, file name, file modified date, all sorts of stuff. Let me see if I can get some better stuff. All right, so like company names, and it's easier to identify anomalies and suspicious things from this. And again, that use of Octopus helps to simplify that and have it automated at your fingertips and come right back into the stack. And real quick, before my time is up, it's going to show you a pretty dashboard where you can visualize all that. I'm not saying it's super pretty, but it's something. But again, we see the 9 logs or the 9 sections that I was referring to, and we see some different details about these. And you can build your dashboard out to include whatever you like. But right off the bat, we see things like the section names, right? The file size, so you can look for things like that. Entropy scores, MIME types. We see the node from which the file came. So if we're trying to find out which Strelka node, if we have a cluster of nodes, came from, we can figure that out pretty easily. Character sets, OSs and subsystems, if it's a DLL or what kind of file it is, and all this other hash information, and lots of good stuff we could add in there. Just there's too many for me to make something that appeals to everybody. It's just you want to tune it to what your organization deems important and is looking for, and just go from there. But other than that, I think that is about it for Strelka. Let me go back. All right. So altogether now, here's kind of, and this was actually, I have not updated this for Velociraptor. This is for when I was using GUR, but still gives you a good idea of kind of the flow of all these things together. Again, you may or may not implement these things together. You may not do these things at all. You may think I'm stupid. But again, just some ideas. And some of the tools that I reference here. And if you want to drop me a line, my information's available here. Just hit me up, and let's have a conversation. And that is it. All right. So, if anybody was paying attention, does anybody know of any? Let me see. I think we'll go. Hold on. Give me 1 second. Take this. Y'all can't cheat. Sorry, I'm terrible with these questions. Can't type my super long password either. right. So, can anybody give me an example of those attributes or the benefits that Strelka can provide? Mhm. Right, that'll work. Okay, I guess I should have announced this, but this is an ETAP 2003. Congratulations. Yeah, man. All right, next up, Blue Team Handbook by none other than Don Murdoch. All right, so can anybody tell me a Cortex analyzer available with Cortex? Anybody remember? Yes, actually there is. Very good. I didn't say that one, but there is, so I couldn't tell you no.
Thank you.
All right, no problem. That's it for the prizes. Sorry, I'm kind of not a great prize presenter, but that's what you get. So thanks for coming, guys. I really appreciate it. Y'all have a good one.